Tonight, we continue our LOL series on physics with the physics of the future, featuring a renowned physicist, author, and popularizer of science. Whether your interest in physics is that of a professional scientist, an enthusiastic amateur, or a complete novice, you've likely encountered this brilliant mind. With multiple New York Times bestsellers, including Physics of the Impossible and, as of just a few hours ago, the newly released Physics of the Future, which debuted at number 7 on the New York Times bestseller list this week. This visionary has captivated audiences worldwide. His regular television appearances on ABC, BBC, the Science Channel, and CNN, along with over 70 articles published in science journals, have made him a household name. He has tackled the great questions of physics and elevated scientific awareness across all levels of understanding. Known to many as the co-founder of string field theory, he's also recognized for his work in explaining the physics behind the series Firefly on the Science Channel. His ability to communicate complex ideas spans a wide range of interests, from cutting-edge theoretical physics to pop culture. In the spirit of great futurists like Jules Verne and Leonardo da Vinci, he takes us on a speculative journey into the future, grounded in interviews with over 300 of today's top scientists. Their groundbreaking research is shaping the future of medicine, computers, artificial intelligence, nanotechnology, energy production, and astronautics. And as if that weren't enough, he was recently voted one of the top 100 smartest people in New York by New York Magazine. Let's see how he resonates with a Boston audience. Please join me in welcoming this extraordinary mind. After such an introduction, I can't wait to hear him speak. First, I have a confession to make. Yes, it's true that New York Magazine voted me one of the 100 smartest people in New York. But in all fairness, I have to admit that Madonna also made that list. So how accurate and authoritative could it really be? Today, I'm going to take you on a guided tour of what scientists believe the next 50 to 100 years will look like. I've had the honor of interviewing over 300 of the world's top scientists, 2 scientists a week on my radio show, Science Fantastic, which broadcasts right here in Boston and reaches 140 radio stations across the United States. I've had the privilege of sharing their dreams about the future. As a physicist, I'm proud to say that we've invented some of the most transformative technologies of the modern era. We invented the transistor, the laser, and helped create the first computer. We played a key role in developing the internet, the World Wide Web, television, radio, microwaves, radar, MRI scans, PET scans, you name it, physicists were there. And now, we're inventing the 21st century. So buckle up, because you're in for a wild ride into the future. Of course, predicting the future is no easy task. Let me quote the great philosopher Yogi Berra: "Prediction is awfully hard to do, especially if it's about the future. But as physicists, we love making predictions. In fact, we predict trillions of years into the future, envisioning what the universe might look like." And let me also quote another great philosopher, Woody Allen: "Eternity is an awful long time, especially toward the end." So let's talk about the future. When physicists helped invent the internet, one of them predicted it would become a forum of high culture, high art, and high society. Well, today, we know that 5% of the internet is pornography. But that's because teenage boys dominate it. Just wait until grandmas and grandpas log on. Then 50% of the internet will be pornography. In my last book, Physics of the Impossible, I explored the world of science fiction, imagining inventions that might take thousands of years to realize, like harnessing the power of black holes, building starships, or creating time machines. I work in string theory, which is the only framework that allows us to make rational statements about time travel. But today we're going to focus on predicting the next 100 years. Some people say it's impossible, but let me give you a counterexample. In 1863, during the American Civil War, Jules Verne predicted the next 100 years. He envisioned moon rockets, getting the size and velocity of the capsule right within 10%. He even predicted weightlessness and the 3-day journey to the moon, launching from Florida and splashing down in the ocean. He got it all right, except for the propulsion system, which hadn't been invented yet. You might think that was a fluke, but he did it twice. In 1863, he wrote Paris in the 20th Century, a novel so outrageous that his editor refused to publish it, saying no one would believe it. It was locked in a safe for over a century until his grandnephew discovered it. The book predicted glass skyscrapers, gasoline-powered automobiles, fax machines, and something resembling the internet, all in Paris by 1960. How did he do it? Whenever a scientist or learned person passed through Paris, Verne would pester them, absorbing their knowledge like a sponge. He wanted to know the future, and that's what I've done. I've interviewed over 300 scientists to understand their visions for the future. When I was a kid, I had two heroes. The first was Albert Einstein. I remember my teacher announcing his death when I was 8 years old. A picture of his desk with the unfinished manuscript of his unified field theory changed my life. I wanted to finish what he started. My second hero was Flash Gordon. Every Saturday morning, I watched him battle aliens in space, but I realized that Flash didn't create anything. It was the scientists who built the starships, the ray guns, and the cities in the sky. That's when I knew I wanted to be a scientist. So let's take a journey to the year 1900. What was life like for our grandparents and great-grandparents? On average, you were lucky to live past 40. Most people were dirt farmers. High tech meant the telegraph. There was no television, no radio. Life was short, brutish, and often miserable. If you could visit your grandparents in 1900, they'd think you were a wizard, talking about rocket ships, atomic bombs, and cars racing at 140 miles per hour. Now fast forward to the year 2100. If your grandkids walked through that door, how would you view them? They'd have the power of gods. They'd mentally control computers, move objects with their minds, and rearrange matter like the deities of mythology. They'd have perfect, ageless bodies and flying cars. They'd bring back extinct animals like mammoths and even Neanderthals. But there's a downside. Will we have the wisdom to handle this godlike power? In Greek mythology, the gods spent most of their time chasing each other and causing mischief. Will we be wise enough to avoid our own Ragnarok? Let's start with today. Moore's Law, the most important chart of the late 20th century, states that computer power doubles every 18 months. By 2020, chips will cost a penny, and computers will be everywhere and nowhere, like electricity today. Your PC will disappear, and intelligence will be embedded in the walls, floors, and ceilings. You'll simply talk to things, and your kids will wonder how you lived in a world where everything was stupid. Every decade brings a new revolution. In the 1960s, we had mainframe computers. In the 1970s, mini-computers. In the 1980s, the PC. In the 1990s, the Internet. In the 2000s, ubiquitous computing. Next, we'll have advanced sensors, more computer power in your bathroom than in a modern hospital, and eventually, control of computers with the mind. The Internet is the magic mirror, reflecting wealth and opportunity. Ignore technology, and you'll be left behind. In the future, the Internet will be in your glasses, recognizing faces, translating languages, and displaying biographies. You'll know exactly who to talk to at a cocktail party. Kids will drive this technology, and fashion models will adopt it as part of high fashion. Your glasses will have GPS, teleconferencing, and your home entertainment center. And if you don't wear glasses, Internet contact lenses, blink and you're online. Imagine MIT students using these during final exams. Why memorize amino acids or the periodic table when you can look it up instantly? The future of science will emphasize concepts and principles, not rote memorization. This is the future we're creating. A future where we wield the power of gods. But the question remains, will we have the wisdom to match? In the future, when you slip on your Internet contact lenses, the world as you know it will transform. Imagine being an artist. Artists will be among the first to embrace this technology. With a simple blink, they'll move their hands, creating breathtaking works of art, rearranging elements in real time, and visualizing their masterpiece through the lens before it even exists. Architects will thrive in this new reality, effortlessly redesigning buildings, shifting rooms, and reimagining spaces with a thought. Fans of Star Trek will recognize this as the holodeck, while Matrix enthusiasts will see it as a step closer to their digital utopia. Even tourists will revel in this innovation. Picture yourself in Rome, standing among the ruins of the Roman Empire. It's disappointing, isn't it? The grandeur is gone, the marble of the Colosseum stripped away to build the Vatican. But in the future, your contact lenses will recreate the Roman Empire in its full glory, allowing you to walk through ancient streets as if you'd traveled back in time. The Chinese have already taken the first steps with the Summer Palace, using PCs to recreate its former splendor before it was destroyed. Tourism will never be the same. The military is equally invested in this technology. Soldiers will wear these lenses to eliminate the fog of war, seeing the battlefield with crystal clarity. This is augmented reality, unlimited virtual information layered onto the real world. Kids love virtual reality for gaming, but augmented reality is the future. Prospectors will use it to locate gold and oil deposits via satellites. Archaeologists will uncover hidden ruins with pinpoint accuracy. You've seen this before in movies. Think of the Terminator scanning its surroundings, identifying targets in real time. But why should robots have all the fun? Why can't we have this power? Tourists, students, and everyday people will use it to see biographies, subtitles, and even through objects. The military will use it to see through their own aircraft, giving pilots X-ray vision to spot enemies below. This is the future of augmented reality, and it's already here. Now let's talk about your living room. With computer chips costing a penny, they'll be embedded in everything. Your wristwatch will become an internet device. Your phone will have multiple screens, and typing on tiny keyboards will be a thing of the past. Instead, you'll unroll intelligent paper, OLED technology where every dot is a transistor. Your wallpaper will change colors and designs with a command. Even your wallet photos will come to life, moving and interacting because chips are cheaper than the paper they're printed on. Your living room will be a 360-degree immersive experience called the cave. Imagine it's Friday night, and you're alone while your friends are out on dates. Instead of drowning your sorrows, you'll ask your wall, "Mirror, mirror on the wall, who's available tonight?" It will scan other screens, find someone compatible, and set up a date. Later, you'll watch Casablanca, but with your face replacing Humphrey Bogart's and your date's face replacing Ingrid Bergman's. The future isn't cold or mechanical, it's personal and emotional. The internet, once a tool for domination, is now about connection. It's gone from male to female, from control to touch. Your kids probably play video games with people in South Africa or Russia, knowing more about someone in Iceland than their next-door neighbor. The internet has expanded our circles from 5 people to 5 million, reshaping the world in ways we never imagined. But this future comes with challenges. The English language is already struggling to keep up. We have smart Barbie dolls and Microsoft Works, contradictions in terms. Chips are everywhere, even in glass. Why should Windows just sit there? In the future, there'll be intelligent screens. Tired of the same view? Change it. Want to see the Eiffel Tower? Or the Taj Mahal? Just ask. 3D TV will no longer require clunky glasses. The screen itself will split images for each eye, creating a seamless 3D experience. Your office will transform too. Computers will be disposable, scribbled on and thrown away like scrap paper. Computing will move to the cloud, metered like water and electricity. Your cubicle will be so immersive, you might spend more time doodling than working. Now let's talk about cars. In 8 years, driverless cars will hit the market. Google is pouring millions into this technology. Picture this, you're in a car, hands off the wheel, not because you're reckless, but because the car drives itself. It uses GPS, radar, and millions of chips embedded in the road to navigate. Traffic jams will vanish as your car communicates with others, finding the fastest route. It's safer than human drivers. No drowsiness, no drunk driving, no distractions. The future of transportation is here, and it's autonomous. But let's go further, into mind control and robots. By mid-century, we'll control machines with our thoughts. Imagine surrogates or avatar come to life. You'll have a perfect robotic body while your aging, mortal self stays at home. Telepathy and telekinesis, the power of the gods, will be within reach. Today, toys already exist that let you move objects with your mind using EEG sensors. This technology will evolve, allowing paralyzed individuals to communicate, write emails, and even play video games using only their thoughts. Stephen Hawking, who currently communicates through facial movements, may soon use this technology to connect with the world mentally. Honda is already developing robots controlled by human thought, bringing science fiction to life. Next time someone tells you to take out the trash, your robotic clone will do it for you. Mind reading is also becoming a reality. When you tell the truth, your brain remains calm. But when you lie, it lights up like a Christmas tree. This technology could revolutionize courts, though its accuracy is still debated. In Tokyo, scientists are even working on photographing dreams. Using brain patterns, they can reconstruct simple images, bringing us closer to understanding the human mind. This is the future, a world where thoughts control reality, where dreams can be captured, and where the line between human and machine blurs. But with great power comes great responsibility. As we gain the ability to control the world with our minds, we must ask, do we have the wisdom to wield this power? The future is thrilling, but it's also a moral challenge. Will we use this technology to uplift humanity, or will we succumb to the chaos of our own creation? The choice is ours. Imagine a world where the power of a god is at your fingertips, where your thoughts can shape reality, create empires, and bring dreams to life. This is the vision of the future. But it comes with a warning. Remember the movie Forbidden Planet? It's one of my favorite science fiction films, and as a kid, it blew my mind. The story revolves around the Krell, a civilization a million years ahead of us. Their crowning achievement was a machine that turned thoughts into reality. Imagine it. You think of something, and it materializes before your eyes. They built entire empires, created robots effortlessly, and even conjured people into existence. But then, in a single night, their civilization collapsed. Why? Because when they turned on their godlike machine, they fell asleep. And when you sleep, you dream, and sometimes you have nightmares. The machine turned their darkest fears into reality, unleashing monsters and chaos that destroyed them. The lesson? Infinite power demands infinite responsibility. Now let's shift gears to medicine, a field on the brink of revolution. Remember the classic sci-fi image of Raquel Welch floating through someone's bloodstream in a tiny submarine? It seemed absurd at the time, but we're getting closer to that reality. Computers are shrinking to unimaginable sizes. Today, we have smart pills, aspirin-sized capsules with tiny cameras and chips inside. You swallow one, and it films your digestive system, guided by magnets, capturing every detail of your stomach and intestines. For middle-aged men who dread colonoscopies, this is a game changer. And it's not just about diagnostics. We're developing nanoparticles, molecules that act as smart bombs against cancer. Unlike chemotherapy, which ravages your body, these nanoparticles target only cancer cells, leaving healthy cells untouched. In one test, they were 90% effective. This is real, and it's happening now. But how do we detect cancer before it's too late? Imagine a future where your toilet becomes your doctor. It analyzes your waste, detecting proteins emitted by cancer cells long before a tumor forms. Today, if you feel a lump in your breast, it's already too late. You have billions of cancer cells growing. But in the future, your toilet will warn you years in advance, giving you a 10-year head start. The word tumor might even disappear from our vocabulary. Hospitals are already working on devices that can detect a single cancer cell in a billion. This isn't science fiction, it's the future of medicine. And let's not forget Star Trek. Remember Spock's tricorder, the device that could diagnose diseases from a distance? People laughed, but we're closer than you think. Today's MRI machines are massive, but scientists are shrinking them. The smallest MRI machine is now just 1 foot tall, and soon it could be the size of a cell phone. Imagine scanning your body at home, seeing your organs in real time. This is the future of healthcare. Now let's talk about DNA, the blueprint of life. We're on the verge of growing organs in labs. Need a new ear? We can grow one using your own cells. The same goes for bones, blood vessels, and even heart valves. The first lab-grown bladder was created 3 years ago, and the first windpipe followed last year. The next frontier, livers. In 5 years, we might be able to grow livers for those in need. For all the alcoholics out there, take heart. Your future might not be as bleak as Mickey Mantle's, who died waiting for a liver transplant. But with great power comes great ethical dilemmas. We've already created smart mice with enhanced intelligence and memory. We've even found a gene that makes mice muscle-bound. the implications for sports are staggering. Imagine athletes genetically enhanced to outperform their competitors. The Olympics are already preparing for this new era of cheating. But there's a brighter side. We're unraveling the secrets of aging. We've discovered 60 genes that regulate how we age. Chimpanzees, who share 98.5% of our DNA, live half as long as we do. By understanding these genes, we might one day slow or even reverse aging. Your grandkids might choose to stay 30 for decades. Let me end with a story about Einstein. When he was old and tired of giving the same speech, his chauffeur, a part-time actor, offered to switch places. The actor delivered the speech flawlessly, but when a mathematician asked a tough question, the chauffeur replied, "That question is so elementary, even my chauffeur can answer it." And with that, I'll take your questions. Imagine a future where jetpacks and flying cars aren't just science fiction, they're reality. But here's the catch. The problem isn't building them, it's powering them. Right now, jetpacks run on hydrogen peroxide, which lasts only a few minutes. You've seen the movies, James Bond soaring through the air, but those scenes are spliced together from multiple takes. The real challenge is longevity. That's where nanotechnology comes in. In the future, nano batteries could power jetpacks for much longer, but for now, hydrogen peroxide is all we've got. Flying cars, they exist. We filmed one for the Discovery Channel. It takes off with massive rotors, just like in the movies, but the gas mileage is a nightmare. You'd have to be a millionaire to afford the fuel bill. The solution? Magnetism. Imagine an ice puck gliding across a rink with zero friction. That's the future of transportation. Superconducting magnets could eliminate friction, making hoverboards and flying cars not just possible, but efficient. We're not there yet. Room temperature superconductors are still a dream. But when we crack it, we'll move from the age of electricity to the age of magnetism. And yes, that means real hoverboards. Now let's talk about cancer. A battle we're slowly but surely winning. I recently had dinner with a leading scientist at the National Institutes of Health. She's working on nanoparticles that target cancer cells with precision. These aren't just lab experiments, they're being used on end-stage cancer patients, people who've been given no hope. And in some cases, the results are miraculous. This isn't a cure-all, every cancer is different, but it's a game changer. We're attacking cancer at the molecular level. Gold nanoparticles, for example, can enter cancer cells and, when hit with a laser, rupture the cell walls. Another approach involves the p53 gene, which is linked to 50% of all common cancers. By delivering Pu53 directly to cancer cells, we can knock them out. This is the future of cancer treatment. Smart bombs that leave healthy cells untouched. But it's not here yet. It'll take years to perfect and get FDA approval. Still, one day, we'll look back at chemotherapy the way we now look at bloodletting, a crude, outdated practice that did more harm than good. Now let's shift to the global stage. Which nations are poised to dominate the future? The answer lies in intellectual capital. The world is moving from commodity-based economies to knowledge-based ones. Take England, it earns more from rock music than from coal mining. Why? Because intellectual capital, art, science, technology can't be mass-produced. You can't crank out a software engineer or a rock star like you can a ton of coal. Nations that understand this will thrive. China gets it. They're sending their best minds to the US, leveraging their cheap labor to build a future based on innovation. But many countries are still stuck in the past, relying on commodities like food production These nations risk being left behind as the world shifts to a knowledge economy. The future belongs to those who can harness creativity, imagination, and human talent, things robots can't replicate. Finally, let's touch on string theory, the most ambitious idea in physics. Will it have practical applications in your lifetime? Probably not. But if we crack longevity and live for centuries, the implications are mind-blowing. String theory is the only framework that can answer questions like, is time travel possible? Can we create wormholes? Are there other dimensions? The Large Hadron Collider is already testing these ideas, searching for evidence of higher dimensions. Critics of string theory often ask for alternatives, but there are none. It's the only game in town, the only theory that's mathematically consistent. It might not change your life tomorrow, but it could redefine reality in the distant future. And then there's nuclear power, a double-edged sword. The disaster in Japan is a grim reminder of its dangers. Nuclear waste is a massive problem. In the US, we have no long-term storage solution, no Yucca Mountain. Waste piles up at power plants, creating a ticking time bomb. But there's hope. Fusion power. By mid-century, we could have fusion reactors that use seawater as fuel, producing no nuclear waste. The French and the European Union are leading the charge, building the ITER fusion reactor set to go online by 2020. Fusion could be the clean, limitless energy source we've been dreaming of. But until then, we're stuck with the Faustian bargain of nuclear power, unlimited energy at a potentially catastrophic cost. So what's next? The future is a mix of breathtaking possibilities and daunting challenges. From jetpacks and cancer-curing nanoparticles to fusion power and string theory, we're on the brink of a new era. But with great power comes great responsibility. The question is, are we ready for it?